Hey! Welcome back to Math Meets Voltage. Today, we are unlocking one of the most important laws in electricity. Ohm's law. It's simple, powerful, and essential if you want to understand how circuits really work. Ohm's law is the rule that links voltage, current, and resistance. It's named after George Simon Ohm, a German physicist who figured this out way back in the 1800s. The formula is simple. V is voltage, measured in volts. I is current, measured in amps. R is resistance, measured in ohms. You can rearrange it depending on what you're solving for. Think of electricity like water in a pipe. The water pressure, pushing the water through the pipe, represents the voltage. The water's flow rate represents the current. The resistance is represented by how narrow or wide the pipe is. A wide pipe lets water run with less restriction, thus representing a small resistance. A narrow pipe restricts and slows the water, thus representing a big resistance. Let's say you have a 9-volt battery connected to a 3-ohm resistor. How much current will flow through the resistor? By rearranging the formula we get our answer to be 3 amps of current. Let's now say that we have a 10-volt battery, and a current of 2 amps going through a resistor whose value is 5 ohms. What would be the voltage drop across the resistor? By directly plugging the values into the formula, we find that the voltage across the resistor is 10 volts. Ohm's law is the foundation for designing circuits. It tells you how much current your components will handle, how much voltage you'll need, and whether things will burn out or run perfectly. If you ever get stuck, just remember the Ohm's law triangle, cover what you're solving for, and what's left tells you the formula. That's a wrap on Ohm's law. It's a simple formula, but with a very huge impact. If this helped you out, please drop a like, hit subscribe, and check out our next episodes where we connect this law to real-world components.